Okay, so in this lecture, we will discuss Nodal Node Method. We will apply this kind of method in solving network circuits. Okay, so this method is part of network laws and theorems. So by definitions, it offers the advantage that a minimum number of equations must be written to determine the desired quantities. And nodal node method consider every junction in the network representing a connection of three or more branches is regarded as a node. So for example, we have a junction here, then we have a connection, first connection, second connection, and another connection. So this one here is considered as node. Then furthermore, we consider one of the nodes as a reference potential point. So the current equations are written based on the remaining junction. So the reference point is for easier applications. We consider the reference point as the uh, negative connections. Okay? All the negative connections, all the branch or circuits connected to the negative side, it's we refer that as zero potential point. Therefore, if we want to find the possible number of equations using the nodal node method, we only we will use this formula n minus 1 equations in which the value of n is the number of nodes. Therefore, if you have 5 nodes, you only have 4 equations to solve that networks. Okay, so continue. Just to illustrate, we have this kind of circuit with or network with 3 nodes. We have 1, 2, and 3. So as you can see, the connections between branches is considered as nodes, and the node 3 or the zero potential point is the connections in which the branches are connected to the negative side of the voltage source. Okay. Now, to find the equations, we will first focus on node 1. Node 1. Okay, so node 1. Now, using Kirchhoff's law, current law, we can get the value of the relationship between I1 that is equal to IA plus I2, in which the current entering the node is equal to the current leaving node. And I1 is equivalent to voltage, the voltage source A minus the voltage at load RA divided by R1. We can get this value using the Kirchhoff's voltage law. Try to review what is the Kirchhoff's voltage law. VA over RA for IA plus VA minus VB or the voltage at RB divided by R2. Again, this is QVL. Now, we simplify these equations. Transpose, we divide AA and VA by R1, VA and BB by R2. Then simplifying, we can get this equation. This will be our first equation. Take note that we have 3 nodes. And in order to solve this kind of circuit that has 3 nodes, we need to find the 2 equations. Okay, so we have the first equation. Next, at node 2. At node 2, we can have the following relations. I2 plus I3, or the current entering the node is equal to the currently being IB. Again, KCL. Using Kirchhoff's voltage law, we can get the respective value equivalent to I2, I3, and IB. Then simplifying, we can get the equation 2. Okay, so this is now the equation 2. For this kind of circuit, you can easily memorize this one if you have this kind of or type of circuit. Say for example, we need to find the value of the voltage across the currents, across the RA and RB, also the currents, given the following information. So we have 120 volts, we have 105 volts, we have for R1 that is 1.5 ohms, 1.5 ohms, then R2 is 3 ohms, then 21 ohms, then 6 ohms. The missing is IB and IA. Also, we need to find the value of the voltage A and voltage at B. Okay. So again, for node 1, we can have the following relations based on the solution in the previous slides. We can now directly substitute the values, and we only have VA and VB known. Okay, so simplifying further, we can get this equation. Say this is your equation 1 for this circuit. 22 over 21 VA minus 1/3 VB equals 80. Next, for node 2, again we have this following relations. Substituting the values the same, we only have VB and VA as unknown. So simplifying further, this equations becomes 1/3 VA plus 7 over 6 VB equals to 70. So this will be our equation 2. Now, equation 1 and equation 2, solving two simultaneous equations for VA and VB, you can use elimination method. Elimination, we have substitution and determinants to find the value of VA, in which that is 105 volts, and VB is equal to 90 volts. Again, to solve these two equations, simultaneous equation, you can use elimination, substitution, and determinants. Therefore, the value of the currents in RA and RB are, using Ohm's law, we have current is directly proportional to voltage, and inversely to the resistance. We can get VA over RA, which RA is equal to 21, 105 divided by 21, that is 5 amperes, and IB is VB over RB is equal to 90 over 6 is equal to 15 amperes. Okay, so I hope you learn in this lecture, this simple lecture, and if you have comments, just leave it in the comment sections, and don't forget to like, comment, and subscribe. Thank you for watching this video.